In the previous video, we learned how to construct sections. In this video, however, we are going to use sections in a very special way. We are going to learn how to prove that a type is contractible. But what does it mean for a type to be contractible? Well, suppose we are given a type A. We then say that the proposition that A is contractible is defined as follows. There exists a term C in A such that we can construct a function that takes any term x in A and returns a path from C to x. In other words, a contractible type can do this. We refer to C as the center of the contraction. But before we can see it in action, we must first go back to the transport function. Suppose we had a type B inhabited by the terms x1, x2, and A, and let there be a path P from x1 to x2 and a path Q from A to x1. We can then apply the transport function to move the path Q from A to x1 to the path P star of Q from A to x2. And yes, we can prove this using path induction. Similarly, we can show that a path from x1 to A can be moved along P to a path from x2 to A, and a path from x1 to itself can be moved along P to a path from x2 to itself. Armed with this knowledge, we can now prove that a type is contractible. Suppose we had a type I inhabited by the terms 0, 1, and a path called segment from 0 to 1. We call this the interval type. We'll pick 1 as the center. We then need to construct a function f that maps every term x in the interval type to a path from x to 1. To construct this section, we let f0 be segment, we let f1 be refill, and finally, to complete the section, we need a path from seg star of f0 to f1. In other words, we need to find a path from seg star seg to refill 1. And we can do so using one of the transport theorems from earlier. But what about the circle type? Well, it turns out if you want to prove that S1 is contractible, you have to prove that refill base is equal to loop. But we cannot do so since there's a hole in the middle. In other words, for a type to be contractible, not only need all the terms be connected, all the holes need to be filled. We now know how to show that a type is contractible in homotopy type theory. Thanks for watching.